Okay, let's go over this one. So, the question you got to ask yourself in each one of these questions is, what kind or kinds, plural, of energy are changing? In both of these questions, only one kind of energy is changing. Okay, so we set these up. Okay, we got, in this first one, we've got a ramp. Okay, we know it's angled at 20 degrees. We know the length of it is 45 meters. Okay, now it tells us here friction is not a factor. So if friction is not a factor, how does the energy at the top of the ramp, the total mechanical, compare to the total mechanical energy at the bottom of the ramp? If there's no friction, it's the same. It doesn't lose any energy on the way down. All that happens is it gets converted from potential to kinetic. Okay, so if they're asking how much work is done by the force rolling the rock, there's two ways to do this. Okay, I could say that work is a change in potential energy. Because I could calculate how much potential energy it has. I just calculate the height of the ramp and calculate the potential energy at the top. Because how much potential will it have at the bottom? Right, and that'll be its change in energy. Or I could calculate F parallel and multiply it by 45, as that's also a force doing the work. Okay? Either gravity is bringing it to the bottom or F parallel is pulling it along the ramp. Either way, its energy changes by the same amount, okay, on the way down, okay, converting potential energy into kinetic. Okay, so I'll show you both ways here. Okay, we got to find this side here, which is just a trig calculation, so that's going to be the sine of 20 times 45. So that'll get me my height. Thought I pressed that already. Okay, so sine of 20 times 45 meters. All right, so the height of this ramp is 15.39 meters. Okay, work is a change in energy, so that'll be mghf minus mghi. That's 0. Okay, so I'm going to have effectively 0 minus 13 kilograms times 9.81 times 15.39 meters. Okay, so 0 minus 13 times 9.81 times 15.39. Whoop, 39. And actually, I should use the whole number. Okay, so we've got negative 1,962.8, but we only have two significant digits, so 2.0, negative 2.0 times 10 to the 3 joules. Okay?
It's negative, right?
It's negative, okay, because from gravity's perspective, it lost gravitational potential energy. Okay, if I was looking at kinetic energy, it'd be positive because it would gain that much kinetic energy, right? Now, if we're looking at F parallel, okay, the method to do F parallel, okay, the first thing I have to do is calculate Fg. So m times g, okay, 13 times 9.81. Whoop, I did wrong there. Oh, I put 2 times in there. 13 times. All right, so I got 127.53. Okay, and then I've got to draw the triangle in here. Okay, I got to get F parallel, which would be the sine of 20 times 127.53. Okay, so 43.62 newtons. Okay, and then I got to go work equals force times distance. which is going to be 43.62 times 45. Oh my gosh. It's the same number. Is that okay? It better be. If it's not the same number, we really screwed up somewhere. Okay? It's the same amount of work, regardless of which way I calculate it. Remember yesterday I told you, you can do any work energy theorem problem as a Newton's second law problem? Okay? I used Newton's second law to do work as force times distance. Was it more steps? Yeah, I did I did 2 steps. I had to get the height of the ramp. Okay? And then I did MGH. Okay? Over here I did FG, F parallel, and then work as force times distance. 3 times as much work.
So, but the answer, is it still negative?
In this case, no.
Yeah, okay.
Because we'd be talking about the gain of kinetic energy in this case. This would be the work F parallel did. Okay? We're losing potential, we're gaining kinetic. In actual fact, the answer, a third answer here is correct also. What would the third answer be that would be correct here? And it would require no work at all. And incidentally, no work at all is a spoiler. 0.
Oh, because it's just potential.
Right. The mechanical energy of this box actually doesn't change. It just converts from potential to kinetic. Its total mechanical energy between the top and the bottom actually hasn't changed. Okay? I would say that in that case, each one of those answers could be considered correct.
Where do you want us to put the marks for these?
So for this one here, if they did this, so give them a mark for Gibbons picture, whatever they had. Okay, mark for this. So that's 1, 2, 3, 4. 2, 3, 4. Final answer. Okay, either way. Okay, for question number 2. Okay, so truck driver is traveling at 14.5 meters per second. Truck has a mass of 1,300 kilograms. Okay, driver slams on the brakes and skids to a stop. All right, VI is 14.5 meters per second. Okay, mass is 1,300 kilograms. Okay, VF is 0 meters per second, okay, and we're looking for the amount of work. All right. What's the only force acting on this truck? Friction. Okay. I can't really use my free body diagram to help me here because I was a bit of a jerk and I didn't give you mu for this question, which makes it impossible to calculate the force of friction. No, it doesn't. Actually, you could do it. You could do this as a Newton's second law, so I'll show you the Newton's second law method as well. Okay, what kind of energy is changing in this question? Kinetic only, right? It's a level road, so only the kinetic energy is changing. So I can write here, work is a change in kinetic energy, which is also a change in mechanical energy, but I don't need to write both because I only have one changing. Okay, so that's going to mean then EK final minus EK initial. But what's my final EK?
0.
Right, because I come to a stop. All right, so I'm going to have kind of the same thing we had in the last question. 0 minus 1/2 MVI squared, which would be 0 minus 1/2 times 1,300 times, what was our speed? 14.5 squared. So 0 minus 0.5 times 1,300 times 14.5 squared. Okay, so we are looking at three significant digits. We are looking at 1.37 times 10 to the 5.
They're both out of 4, right?
What's that?
They're both out of 4.
Both methods, yes, yeah, it's out of 4. Okay, now, here's the other way you can do this one.
Should that not be negative?
Yes, it should be negative. Okay, now, here's the other way you can do this one. As a Newton's second law question, friction is the only force. Therefore, it is the net force. Okay, so can I calculate the acceleration? Oh, no, I can't. No, I can't do it. I didn't give you the distance. That's what I didn't give you. Nope, you can't do it that way, because I was a jerk. I knew I kept something out of there, so you couldn't do it that way. If I'd have given you time or distance, could you have done this? Yes. Okay, would it have taken you a lot longer? Calculate acceleration, calculate net force, then go work as force times distance. 3 steps instead of 1. I don't know about you, but I like to work smarter, not harder. Except when I'm having one of those days where I'm not very smart and I work harder. Yeah, I have a lot of those days. All right, give them a mark out of 8 at the top, and then bring them up to me.